Hi guys, there are a couple of questions from section 2.2. Section 2.2, the first one is number 9. So we have our function capital F of x is e to the 2x over x to the 4. So I'm sure one of the reasons why they gave us this problem or this function differentiate in this section, because in this section you did learn how to differentiate e to a function. So I'm just going to put the two rules real quick. Now, of course, we know the derivative, d dx. Don't forget, d dx just means derivative. It's just notation for the derivative of e to the x, of course, is e to the x. So derivative of e to the x is e to the x. I'm sure you saw that rule in this section. Now, what happened when the x becomes some function of x, like 2x or other function? So that's the more general rule that says derivative of e to any function of x is e to that same function, and then times the derivative of the function. Don't forget that part. Okay, so there is your, basically the rule, the new rule that you learned in this section. So we're going to have to apply that because obviously we do have e to the 2x. So now we do also have a quotient. So to differentiate capital F, we're going to start with the quotient rule that says the bottom. So this is your bottom function. I'm going to again put derivative inside the bracket and derivative top. Now once you get to derivative top, you do have to apply this rule in this section. That's the derivative of e to any function is e to that same function. So you kind of write that again, and then times the derivative of the function that e is being raised to. So our function is 2x. Of course, its derivative would be simply 2. Okay, so here's your first half on the top of your quotient rule, and then minus the top, which is e to the 2x, and then times the derivative bottom. Derivative of x to the 4, of course, is 4x cubed. Okay, and then don't forget over the bottom is square. So step number 1 was just to go through quotient rule. Now this is pretty much this derivative, except we're going to clean it up a little bit. So we have, I'm going to put the 2 in front. So it's 2x to the 4 e to the 2x, and then also minus 4x cubed. I always like to put my expression before the e. 4x cubed times e to the 2x. Now you also have x to the 4 squared. Now as you remember from algebra, when you have two exponents on top of each other, you multiply them. So 4 times 2 becomes 8. Okay, so now the only thing we can do, of course, as far as simplification, is to factor what's common. Between 2 and 4, obviously, you can factor 2 out. Between x to the 4 and x cubed, you can take out x cubed. Also, e to the 2x is in common to both. You can actually pull the whole e to the 2x. So as you factor that out, so from the first term, the 2's cancel. X to the 4 divided by x cubed leaves you with one more factor of x. Also, as you take the second, of course, e to the 2x's cancel each other. 4 divided by 2 becomes 2. X cubed will cancel, also e to the x. So all you get there is just x minus 2. And then over x to the 8. And the last thing we can do is, obviously, as you can see, there is x cubed, there is x to the 8. So 3 factor down here cancel, leaves you with 5 more factors. So this should be your final answer. 2, well, x cubed went away because we've canceled 3 factor of x's. So you're just left with a 2 e to the 2x times x minus 2, and then all over x to the 5th power. And that's pretty much as simplified as you can get your derivative for this function. Okay, so let me just kind of stop that here, and then I'll make the video in the next problem. Okay.